and another one on maintainable weep hole filters. And that actually leads me right into segueing into John Bruinsma's talk. John is from Michigan DOT, and Michigan DOT partnered with Jet Filters, who has a booth in our exhibit hall there. And we have an independent consultant, I think it's Lorella Angelini, and she's following the project and is developing the interim and the final reports of what happened for this jet filter installation. So if you want to introduce John now?
You've done it all. Keep going.
All right. Then I'll invite John to come up while I finish up here. John is going to talk to you about the project that Michigan DOT has underway in implementing jet filter sustainable weep hole filters. And just as a final note, I copied the website URL, but if you just go to the TSP2 website, click the bridge preservation link, along the side you'll see a link for innovative demonstrations, and you can find there's about maybe a dozen or so reports available already, and I expect there'll be more as as the program continues and we get additional projects underway. So,
my name is John Bruinsma. I'm with the Michigan DOT, so a little far out of the northern area where I'm from, but I appreciate you having me here today. I'm here to talk about the innovative technology demonstration pilot project that the Michigan DOT had the pleasure of working with Jet Filter System on. To give a little background about me, I am the region bridge engineer, one of 6 people across the state that look at the inspection, bridge maintenance, and then preservation techniques. We have about 970 structures that my team and I look after across 13 counties in West Michigan. So to give a brief overview, I'll begin by going over a similar project from 2017 that we worked with Jet Filter System on, and then go into the ITD project from 2019, and finish up by discussing our plans moving forward with this technology. So to give some context, in Michigan we inspect all structures greater than 10-foot span at least once every 24 months. Until recently, this year actually, we did not routinely inspect culverts less than 10-foot span. So we were a little more reactive with those structures. We typically address them as part of road projects that were in the area. Now in November of 2017, our maintenance staff noticed several sinkholes, as you can see in the left photo, near a cross culvert under Interstate 96, which is a freeway in West Michigan carrying about 17,000 vehicles per day. Further investigation revealed there were voids present underneath the concrete roadway up to about 10 foot behind the culvert walls. The concrete roadway had bridged those voids to that point, but we were worried about a sudden failure at any point. So it's a little hard to see in the diagram on the left there, but this culvert was originally designed with something called weep holes. Holes in the culvert walls meant to relieve hydrostatic pressure from behind the wall while retaining backfill. As with many of our culverts built prior to the 1990s, this culvert had a sand and gravel filter pocket behind each weep hole meant to retain the fill while letting water through. Now, as you can see in the middle photo there, at many locations, that sand and gravel filter pocket had failed. So what was happening was when water was rising within the culvert above the weep holes, it would suck the backfill from behind the walls and create the voids underneath the roadway behind that. The photo on the right, there's 2 of them there, shows the original culvert had these 3-inch diameter round weep holes from the 1950s. And then when it was extended in the 80s, it had these 4 by 4.5-inch rectangular weep holes. So 2 different types for us to deal with, about 42 total. So our goals with this 2017 project were, 1, to address the immediate safety concern, the voids under the roadway, and then to restore the original function of the weep holes so we didn't have this problem again. We didn't want hydrostatic pressure to build up behind and backfill to come through the weep holes. So we filled the voids under the freeway by pressure grouting, which was the first time we had done that, I think, in our region at least. And then we installed these 2.5-inch diameter stainless steel weep hole filters, as you can see on the left there. As the photo in the middle shows, one unique thing about this project was the specially fabricated adapter plates. So that really standardized the process between the 2 types of weep holes, the rectangular and the round ones, because it accommodated the filters. And the photo on the right shows a profile view of the filter unit. So there's that conical steel portion in the back. There's a filter fabric within that, a cartridge that stops fines but lets water through. And I should note that these 2.5-inch diameter units are not manufactured anymore. They have been replaced by the 3-inch units. So once installed, water flowed from the weep hole filters right away, which meant that they're functioning as intended, which was good. Total cost was about $73,000, most of which was the cost of the pressure gouting. The filters were about $22,000, and this was an emergency job, so contractors don't always do us any favors, I guess, with prices, so there's a little more than we normally would expect. So given our experience with this weep hole filter technology on the previous project, we were very interested in partnering with Jet Filter Systems in 2019 on this ITD pilot project. So our goals with this project were, one, to fix the problems on this culvert you see here, and then two, to really learn alongside Jet Filter System how different filter configurations and fabric types perform. The Michigan DOT typically engages in evidence-based maintenance, so given a certain input, we want to know what the likely outcome is going to be. And this ITD project provided an opportunity to vary certain inputs and then measure or quantify their effects on the overall filter performance. So for example, we could vary filter size, end treatment, or fabric type, and then measure the associated effects. And then with this information, we could then tailor future installations based on site conditions. So a similar problem at this location as with the first example. Backfill had been coming out of the weep holes, and to prevent that, at some point in the past, we had put these rubber stoppers you can see in the photo on the left, or grout. So really that stopped one problem, but it created another, because as you can see on the right there, water and fines were coming out the vertical cracks in the walls. In fact, the water had built up so high that it was even coming through the ceiling of the culvert, which you can see in the middle photo. So we could epoxy inject those cracks to stop those leaks, but that really wouldn't solve the problem, and you'd still have the hydrostatic pressure built up behind the walls. So we wanted to address the root cause of the problem instead. I was always taught a stitch in time saves 9. So in other words, preventive maintenance early on can save considerable cost and effort later on. By fixing the problem now, before we got significant voids behind the walls and roadway undermining, we really wanted to keep it in good condition and keep the motoring public safe. So the installation of these maintainable weep hole filters was intended to relieve the water pressure from behind the walls while preventing loss of backfill, so we didn't get voids behind the walls. For our installation plan, starting at one end of the culvert, we labeled the holes 1 through 26. So there were 52 total, one in the north, or half in the north, half in the south. We varied the weep hole filter size, end treatment, and geotextile filter fabric type based on a predetermined installation plan. So for example, at some locations, we kept the 4-inch diameter unit and geotextile filter fabric constant while varying between the open and closed ended. You can see that in the left and the middle photos there. In another location, we held the 2.5-inch diameter filter unit and open-ended treatment constant and varied between 5 different filter fabric types, 4 woven and 1 non-woven. With such variation, it was pretty important for us to keep track of what was at each location. So we had an ID tag made that had all the information attached to it so that we could see that during future inspections. We were initially planning to core drill around the existing 3-inch diameter weep holes to place the larger 4-inch diameter filters. But you can see in the left photo there, there's some deterioration below a lot of the weep holes, which would prevent a good seal between the filter gasket and the face of the concrete wall. So to accommodate that situation, we were able to core new 4-inch diameter holes in the walls adjacent to the plugged weep holes, and that coring operation is on the right. So if you'll recall, I mentioned the aggregate filter pocket behind weep holes originally present. Once cored, only one of the 52 locations had any aggregate remaining, so the rest had just come into the middle of the culvert at some point. And you can see that in the middle photo there. At the remaining 51 locations, there was a high-pressure slurry, like sand and water, that came out after the cores were pulled. We had 2 days scheduled for the coring and maintainable weep hole filter installation. On the first day, we did 26 filters by about 2 to 3 p.m. Second day, we diverted flow to the second culvert barrel and then finished up the filter installation a little faster since we had it pretty dialed in by that point. And overall, our maintenance forces installed 52 filters in less than 2 work days. That includes the coring operation, which is not all that fast. The project cost was just over $20,000, about $5,000 for MDOT labor and materials, $5,000 for the coring, and then a little over $11,000 for the filters. So at this point, I'd like to show a video of the installation that David Hallman put together.
Initially, when we pull the core, you never know what pressure really going to get right away, but normally there's a lot of dry sand. Makes our filter hard to push in at first. So we'll pull the core, let it drain, and then once it starts getting to be kind of watery, kind of lubricates the filter as you put it in the wall. It's easier to seat up against the wall. Now this one's wet right off the bat, so this one will go right in. And once it's seated up against the wall kind of tight, Tim checks the bottom, make sure we're making contact. Then we'll start drilling pilot holes for lag screws. I don't initially torque the lag screws down tight right away. Then we kind of go around it again and tap it with a rubber mallet just to get it as tight as we can. And then I'll just go around again and tighten them until it feels like the screws are tied up against the washers, where the washers won't spin.
All right, so as you can see, the weep hole functionality has been restored, and once again, we're getting the performance that we'd like. One interesting thing to note that we noticed while we're out there was once those maintainable weep hole filters were installed, those vertical cracks in the walls stopped leaking it almost completely, and you can see that in the left photo there. For this particular culvert, the 4-inch diameter drains seem to be performing better than the 2.5-inch diameter drains, which is to be expected. There's a higher flow rate, and they're also easier to inspect. Inspection of the ones on the right there, the open-ended 4-inch units, are especially easy because you can just peek in the end and make sure there's no fabric clogging, no disassembly required. For this particular culvert, the louvered end treatment you see in the middle doesn't appear necessary. It's got a one-way valve behind there too, but I think in other applications that would be pretty handy. And there's been really no maintaining or cleaning of the geotextile fabric necessary to date. So during follow-up inspections, one thing that was done was to check the flow rate through the weep hole filter, and that's shown in the graph on the left. As you can see, immediately after installation, the flow rate was quite high, indicating pressure had built up behind the walls. And then over about a month, the flow rate reduced to the point where weep holes were doing what they're intended. They're weeping. And you can also see there were different flow rates for different locations, and you could see that during the installation too. Some places had more high pressure slurry than others. It appears water was getting to some places faster than others. And then on the right there, there's water samples taken immediately after installation and then about 2 weeks later. As you can see, with the backfill disturbed after installation, some of the samples have some sediment in there. And then about 10 days later, all filters had the same, they were all clear. So it was, the fabric is doing what it's supposed to do. And then some of the filters were removed during follow-up inspections by the consultant and checking for fabric clogging. And really, there was none noted. The 4 woven fabrics seem to be performing a little better than the non-woven. I think we'll get more longevity out of those woven fabrics. And at this point, we plan to make sampling part of the routine safety inspection. So if we go after a rain event, we can see which locations are not dripping, and then we can go there, remove the cartridge, rinse it in the water, put it back in. It takes about 2 to 3 minutes to inspect it, maintain it. That should be pretty quick. So I look forward to applying this information gained during the ITD pilot project toward future installations. So as far as future plans go, in Michigan, we've got about 1,200 culverts on our state trunkline system, most of which could have weep holes based on their age. On a statewide level, we've been pretty happy with the sustainable weep hole filters by jet filter system and plan to continue using them on our infrastructure. So to that end, a special provision was developed, reviewed, and approved for use on future DOT projects, which you can see there on the right. We also have kind of a pet project of mine, I guess. There's a new box culvert we're putting in where we're going to use these maintainable weep hole filters instead of having a sock pipe behind the wall, so we can kind of see what's going on. And the precaster will place these 4-inch diameter access holes in the walls in their yard, and then the contractor in their field would add these drains. So thank you for your time and attention. I'm happy to answer any questions if I can.
Great presentation, John. I'm curious on how you determined the number of filters for some of the repairs. You mentioned 52 went in. Why not 48, 60?
Yeah, we had 52 weep holes, so we put these in every one of them.
Oh, okay, so you just went with the original number.
Yeah, yep.
Very nice presentation. I want to make 2 observations and then ask my question. First of all, I love the ITD group. I'm part of it. and it gives an opportunity to test things in real life under the auspices of an engineer, so it's documentable and it really shows how products perform. The other thing is, this is the perfect one to test because it's not a product you'd put on a quality products list. And it really shows that it can perform, and there's no other way to really show how something like this is going to perform. My question is, how often do you have to clean them? And I know it'll vary from case to case.
So this went in 2019. We've done the follow-up inspections every, I think it was 3, 6, 12 months. And we have removed a sample at each, like not all of them at every time, but a sample each time. And really not much fabric clogging noted. So we did clean them since they were out. But I would think it's been 2 years, so we haven't had any then. Maybe every 4 or 6 years. It's hard to say, I guess. It probably depends on location, but I guess for us, the main problem was there was the iron ochre buildup. I don't know if you guys see that. I didn't really clog them. It just looked bad.
When you talked about the pressure grouting, what kind of material did you use? Was there any concerns about the permeability of what you pumped down in there?
Yeah, we were a little concerned about that. So we had someone in the culvert at all times while the pressure grouting was taking place, just to make sure that it didn't come out the weep holes. And I think at some locations it did. So for that one, we just kind of sealed up those weep holes and did the other ones. But I guess after that operation was done and the weep holes were installed, water flowed through the remaining ones. So we did notice that those were functioning as intended. But that's a good question. Yeah.
I'm just curious. Did you had any means of determining how much water was behind that culvert when you drill the core and pull it out? What I'm going to is, if there have been a lot of water out there with some sandy soil, maybe you could actually create another void in the back under the road.
Yeah, that's a good question. So once we pulled the core, we had kind of like a sampler that we kind of rammed in each core just to kind of see how big the voids were. So if they were not that big here, but if they were big, then we were going to go in and do some kind of operation up top too. But we didn't have to here, thankfully.
Hi, I'm Annette Adams from Fredericksburg District in Virginia, DOT. I just want to let the team know, the group know, that we installed these filters on one of our structures that was subject to tidal flow. We were continuously losing the road. Our area headquarters men were fighting that constantly. Come to find out, we were losing the backfill due to this tidal influx, and it was just pulling it away. So we installed these filters, and they have been working great. We have not lost the road since, and we have not had to clean them out, and they have been installed for 2.5 years now, so they are working as designed.
Well, thank you very much.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.